Okay, students. So this week we're focusing on chapter 3, linear analysis. Before the break, we had cover and introduction done on the table of contents. Then the first week of distance learning, you started working from equations. So you started with two equations, one in slope-intercept form and one in standard form, and you have to write their t-tables and graphs for each one. Then in chapter 2, you started writing the equations. So with the t-table and with the graph, you wrote equations for them. And this week, we're going to look at linear analysis, which is when we look at all our equations, how can we determine whether they are proportional or non-proportional, increasing or decreasing, parallel or perpendicular, and how steep they are compared to one another. So this week, we're working on chapter 3, and next week is where your whole book project is due. So you'll be submitting all the chapters all together. You should be sending drafts of your work so that we can give you feedback and comment them back to you. We're definitely trying to grade them as fast as possible, and quite a few of you guys have had feedback already. If you haven't had feedback yet, you need to make sure that you turn in your work so that we can give you feedback. Otherwise, it can't happen if we don't see your work. With that said, we'll start with chapter 3 by reading the instructions. How can you compare lines by looking at their equations? So we're going to specifically focus on equations. List all 4 equations in slope-intercept form from the previous chapters. You may add more equations if you want. Show and explain how they compare with each other. So we'll start with the first part. List all 4 equations in slope-intercept form from the previous chapters. And we may need to add more equations to show how they're proportional, increasing, decreasing, parallel, perpendicular, and how they compare in steepness. So I'm going to go to my whiteboard, and I want to make sure that I do that correctly. So I'll put new share and go to whiteboard. Okay, so make this a little bigger. Okay, so with 4 equations, the first equation I have from my previous chapters, chapter 1 and 2, is y equals negative 3/4 x. Let me rewrite that. That's very sloppy. Okay, so y equals negative 3/4 x plus 7. And my second equation is y equals negative 1/5 x minus 2. And my third equation is y equals 4/7 x plus 20/7. And my last equation from my chapter 1 and 2 write-ups is, let's go back. Y equals to negative 3x minus 9. When we have all 4 of these equations, we need to be able to categorize them, whether they're proportional or non-proportional first. So right now, I'm going to have one column that says proportional and the other column that is called non-proportional. And if you recall, when we're looking at proportionality, we need to specifically look at the y-intercept, which is the last term, or the term that doesn't have an x next to it, in y equals mx plus b. So we're looking specifically at b. And if b is 0, we know that this is considered proportional. And if b is non-zero, so any other number except for 0, we know it's non-proportional. So based on these equations, we can see that y equals negative 4x plus 7 is going to be non-proportional because the y-intercept is not 0. It's 7 in this case. And then the equation y equals negative 1/5 x is also non-proportional because there's a -2 for the y-intercept. Same goes with y equals 4/7 x plus 20/7 with the y-intercept of 20/7. And then same applies with y equals negative 3x minus 9 because the y-intercept is negative 9. So you showed your understanding of what non-proportional means, but we still also have to show our understanding what proportional is. So we can create our own example to show what proportional looks like. And that could be y equals negative 3/4 x. That is proportional, or y equals negative 1/5 x, and so forth. So proportional has a y-intercept that is 0. I also want to mention that everything I've done so far is only showing how to do the math. You also have to explain. So you want to write in complete sentences how you're describing what proportional is and what non-proportional is. This will not get you full credit. In fact, many of the students who only did math ended up getting a revise on the rubric. And that is because when we take a look at the rubric, you'll notice that there are 2 parts. It says shortcuts are shown, and that's what I just did. I showed you how to classify them as proportional and non-proportional, but they also need to be explained clearly and completely. So that's where you need to write your sentences to explain how you know it's proportional and non-proportional. Remember, this is a book, so there needs to be a lot of text also. So going back, now that we classified them as proportional and non-proportional, and you saw that I made some extra equations to help support that, we're going to go jump into steepness as our next category. So I'm going to clear all this right here. And there still was a faster way of doing that. Oh well, okay. I see there may be some questions. Okay, that doesn't apply at the moment. Are there any questions before we move on past proportionality? If you have questions, just unmute yourself and then I can answer them. Okay, so now we're going to take a look at steepness. So when you're looking at steepness, you can organize them from least to most steep or most to least steep. We'll look at it from least to most in this case. And when you're trying to find steepness, you need to specifically look at the m value, the slope. The slope tells you how steep something is. And as an example, you can also graph these equations to show how steep they are. So negative 3/4 plus 7. So if I start at 7 right here, and then negative 3/4, it could look something like that. And then negative 1/5 x minus 2. So I start at negative 2, negative 1/5. So that's going to look something like that. And then plus 20/7 is my y-intercept. So 20 divided by 7 is about 2 point something. So let's say it's right here. 20/7, 4/7. So it looks something like that. And then negative 3x minus 9. So start at negative 9. And this is just a quick sketch. Negative 3 should look something like that. You can also take a look at steepness by graphing them. This is a super quick sketch. And you can see that steepness refers to how inclined the angle is. And you can see that this is super inclined compared to some of these other equations. And this is all based on the slope. The slope determines the level of incline on the graph. So if we were to organize this by steepness, just by looking at the slope, we should be able to tell that y equals negative 3x minus 9 is the steepest one based on the slope, negative 3. And steepness does not depend on whether it's positive or negative. It has to do more with the value of the slope. So the next most steep, I converted all of these to decimals. This is about 0.75, 0.2, and this is under it's a little over 0.5. So 0.75 would be the next steepest. It's higher than 0.5. So what it is, the next steepest equation is going to be y equals negative 3/4 x plus 7. And then after that, we would have the 4/7 as the next steepest, because it's a little over half. And then our least steep is going to be 0.2. So y equals negative 1/5 x plus minus 2. So this is in order from least to most steep. And recognize that the negative and positive signs don't matter. It's more about the growth, the level of incline for our slopes. Are there any questions about steepness? If so, just unmute yourself or raise your hand. Okay, so after discussing about steepness, we'll take a look at increasing and decreasing. When we look at these equations, you can tell when a graph is increasing when it's moving left to right going up. So I'll color that in green to show it increasing. And you can tell when a line is decreasing when the slope is going down from left to right. So imagine you're on a bike, you're going downhill in this case. If you're on a bike over here, you're going uphill. So we have one equation that is going uphill and 3 equations that are going downhill. So the equations that are increasing, there's only one, and that will be the one with the y-intercept of 20/7. So this one is increasing. The ones that are decreasing, and I'll make that in red. The ones that are decreasing are all the ones in red, and those are decreasing. Once again, I've only showed you how to determine whether it's increasing or decreasing. I have not explained why it's increasing or decreasing. So make sure you do that in writing. Any questions about increasing or decreasing? Okay, last but not least, we want to look at parallel or perpendicular. So I'm going to clear this part right here. And you can already tell by the graph that based on my sketches, none of these are actually parallel. And as a reminder, parallel means lines never touch each other, regardless of how far you go. And you can see that these two right here, the one that is at 7 and the one that is at -2, they almost look parallel, but they're not parallel. And for it to be perpendicular, they have to intersect and form a 90-degree angle. This kind of looks like it, but they're not exactly 90 degrees. I also mentioned in the weekly assignments that part of your homework is to make sure that you write down what the word of the week is. That tells me if you're watching the video, and if you're in this live lesson, you're basically watching the video because the live lesson is very similar to the video. The word of the week is point of intersection. You want to write this down somewhere, point of intersection. This is how you're going to get full credit on your homework for the week. So write down the word point of intersection at the top of your paper next to your name. So for example, let's say you turned in this assignment where you write your name at the very top. So you write your name at the very top. Make sure the word point of intersection is also at the very top. That tells me that you watched the video for the week. Jumping back to our whiteboard. You write it on just chapter 3 because I'm starting this new trend now. Last week we did not have a word of the week. Okay, so we're going to go to the next part. And if you're wondering what that word means, you're going to learn more about it in our next unit, Systems of Equations. And just to give you some context, next week, the final book project will be due. So you have a week to brush up on all your drafts and create a final version. And then 2 weeks from now, we'll start a new unit, which is Systems of Equations. Moving forward, we're going to do our last part, which is parallel and perpendicular. We can tell when equations are parallel when they never touch each other. So if I were to construct a graph and these two lines never touch each other, that is one squiggly y-axis. These two lines never touch each other. You'll notice that the y-intercept is different, but the level of incline is exactly the same if you were to draw the slope triangles. So to find a line that is parallel to an equation, you want to maintain the same slope but a different y-intercept. You can see that both of these have different y-intercepts. The slopes are the same though. So if I wanted to make a equation parallel to this, I can say y equals -3/4 x plus 2. If I want to make a parallel equation to this, keep the same slope, change the y-intercept. If I want to make a parallel equation to y equals 4/7x plus 20/7, keep the same slope, change the y-intercept. I'm going to have a 0 y-intercept in this case. And similarly, y equals -3x minus 1000 is this parallel to y equals -3x minus 9. These are examples of parallel equations to the original equation. Any questions about parallel? Okay, so the last piece we're going to look at is perpendicular. And graphically, when you're looking at perpendicular, you want to see that when the lines are crossing each other, they need to form a 90-degree angle. And that is formed when one slope is a negative reciprocal of the other slope. So let's say the slope for this one was a over b. Sorry, this is negative a over b because it's going down, negative a over b. If you want to find a line that is perpendicular to it, you need to have a slope that is opposite reciprocal. So instead of negative, it will be positive, and it's b over a. So one is positive and one is negative, and the slope for the change in y and the change in x are basically flipped. And you can see in this example right here, if I wanted to write a perpendicular equation, I would change the slope where it's the reciprocal, opposite reciprocal, and negative reciprocal. So instead of negative, it will be positive. And instead of 3/4, it will be 4/3. and it could be any one, so it doesn't matter. Instead of negative 1 over 5, we make it positive, and instead of 1 over 5, it's 5 over 1. Minus 10, and I think you get the rest. So y equals 4 over 7x, this is positive, so I need to make it negative. Negative 7 over 4, take the reciprocal, x plus 500, and so forth, okay? One thing I do want to remind students is that when you're submitting work, I've gotten the habit of just returning the work back if your work submission is too tiny. That happens where, like, for example, there's this whole page right here. And then when I open the document, what I see is a picture that is this big. I am not going to read that picture. I submit it back and say, send it as a PDF. I've created multiple tutorials to help you learn how to submit your work. Please practice doing it correctly. Are there any last questions before we break out so we can help support students on their book project? Okay, so with that